Okay, today we're talking about solving quadratics by finding the square roots. So there are times when there's no middle term, and the most expedient way to solve for the roots of a quadratic is simply to take a square root. So just to review for a moment, we did simplify roots earlier this year, and the way we did it was we said we were looking for a perfect square in here. We look for factors of 25, look at A. We're looking for factors of 25, and they are 5 and 5. And so you can take the square root out of the radical, and so the answer here is simply 5. So let's do that again here. So we're looking for factors of 125. That would be 5 and 25. And again, 25 is 5 times 5. That's a perfect square. We take the perfect square out of the radical, and what's left inside is whatever was not a perfect square. So we leave that 5 underneath the radical, and we take a 5 out. So the square root of 125 is actually equal to 5 times the square root of 5. And again, look at C. This is just 6 times 4. 4 is a perfect square. So you can take 2 out, and we'll leave 6 underneath. So this is a simplified root there. So 2 times the square root of 6 is equal to the square root of 24. Solve the following equations for x. Well, look at A here. All we're going to do is, if we wanted to solve for x, we're going to need to square root x. And that's the opposite of squaring. That's how we're going to get it to say x equals something, which is the goal here, right? We want to know what the solution is. So when we do that, when we square root, we also have to square root the other side. When you square root 16, you get 4. But here's the key. There's actually 2 ways that you could get 16 here. You could use a positive 4 or a negative 4. So let me walk you through that. If I took a positive 4 and I squared it, I would get a positive 16. And if I took a negative 4 and I squared that, I would still get a positive 16. So it turns out that there are actually 2 solutions here, plus or minus 4. And again, let's do this one, B, right? Look at x squared equals 4. To get x alone, to make it say x equals something, I'm going to have to square root this side. And so I'm going to have to square root this side as well. So when I do that, I get 2, but not just 2. I could actually have a positive 2 or a negative 2 make 4. And again, that would be like this. If I took a positive 2 and I squared it, I would get 4. And if I took a negative 2 and I squared it, I would also get 4. So there's actually 2 solutions here. X is equal to positive 2 and x is equal to negative 2. And again, if I wanted to get x squared equals 9 to say x equals something, right? What I'm going to have to do is take a square root. And let me just break that down for a moment here. If I said square 3, you would say 9. If I said square root 9, you would say 3. So then if I said square 3 and square root it, you would say 3. So the point is that square rooting is the opposite of squaring, and that's why this works. So here, we're going to square root x squared. We're going to square root 9. And when we do that, we get x equals plus or minus 3. There's 2 ways to make 9. Square a positive 3 or a negative 3. Either way will work. So there's 2 solutions to this quadratic. And here for D, just square root this side, square root that side, so you get x equals plus or minus 1. All right, so then here's some rules to play by, some steps, a step-by-step for solving quadratics by finding the square roots. So we're going to add or subtract any constants that are on the same side of x squared. Then we're going to multiply and divide by any constants from the x squared term, right? We're going to get x by itself. Then we'll take the square root of both sides and set equal to positive or negative roots. So we're going to get a positive and a negative answer. All right, both of them will exist. So here, again, we're going to square root both sides. We'll get x equals plus or minus 7. 2 solutions. Square root this, we get x equals the square root of 20. plus or minus, right? And we could simplify this if you want. This is actually, if you do the math on simplifying this, which is not that important, but just as a refresher, you would do, for example, 10 times 2, right? That would get you 20. And so then 2 times 5. And so there's a perfect square right here. We can take the 2 out, and we'll keep the 5 underneath the radical. So actually, this is 5 times the square root of 2, plus or minus. And then again, here, square root both sides. Can you square root 0? Yeah, you can. You don't get a plus or minus. There's no such thing as a plus or minus 0, but you do get 0. So x equals 0. There's just one solution there. Here, we're going to divide by 3 first. And when you divide 108 by 3, you get 36. And so when you square root both sides, you'll get x equals plus or minus 6. And here, you're going to add 11 to both sides. So you get 25, x equals 25. When you square root both sides, you're going to get x equals plus or minus 25, or rather 5, plus or minus 5, two solutions. Here you'll add 6 to both sides. You get 7x squared equals 63. When you divide by 7, you get x squared equals 9. When you square root both sides, you get x equals plus or minus 9, or plus or minus 3. And finally, let's do this one. We're going to add 6 to both sides. Do that, you get 80. So you get 4x squared equals 80. We're going to divide both sides by 4. So we get x squared equals 20. We'll square root both sides. When you square root, you get 5 times the square root of 2 and x, right? But it's plus or minus. So there's 2 solutions.